Hello everyone, welcome to another Disamtex training video. Today I'd like to introduce you to another product family of Disamtex chemicals, which is a paint additive manufacturer situated in the south hemisphere of the globe in Brazil. Disamtex is a specialist in chemical additive solutions for three industries: paint, paper, and textile. And within the paint additives universe, Disamtex has a wide range of product families, which you can check in the description box below. And today I'm going to talk about dispersants. So feel free to comment what you think after watching the video, and let's get started. Dispersants evenly distribute organic and inorganic pigments, as well as mineral fillers, present in the enamel medium. Disamtex has traditionally focused on dispersants specifically for pigment grinding, often providing combinations or pre-selected sets of products from different categories to be used together in the formulations, like a combo. Well, this slide shows how pigment surface area, oil absorption, and particle size are directly related and why they matter in paint formulation. Pigments with smaller particles, like carbon black, have a much higher surface area, which dramatically increases demand for oil present in the resin. Higher oil absorption means more binder and stronger dispersants are required to properly wet and stabilize the pigment. And the particle size chart on the right side also explains why some pigments behave as sedimentary while others remain well suspended. So in practice, these properties define viscosity, stability, color, strength, and overall formulation difficulty. This slide summarizes the four essential steps for proper pigment dispersion. First, incorporation ensures the pigment is uniformly introduced into the liquid. Then, wetting replaces air at the pigment surface with resin, preventing microbubbles and poor color development. And the dispersion grinding step applies mechanical energy to break down agglomerates to the target particle size. And finally, the fourth step, stabilization, keeps the particles separated over time, avoiding flocculation, settling, and viscosity drift. Dispersing involves applying a shear force to de-agglomerate mineral particles as small and equally distributed as possible. That's the main aim. Several aspects here are considered, like the density, homogeneity, distribution of the particles in the medium. And why? Because they influence on the final properties. So the more effective the dispersion, more intense the color is. If the particles remain suspended and well dispersed in the media, this will also prevent pigment to settle, sedimentation process, or go up, flotation process. So check how dispersant selection depends on pigment chemistry. Inorganic pigments interact best with dispersants containing acidic anchoring groups such as phosphates, sulfates, carboxylates. Organic pigments require dispersants with aromatic groups like phenyl or naphthyl to ensure strong surface affinity. Carbon blacks, due to their surface chemistry and high area, are best stabilized with nitrogen-containing dispersants. The table summarizes how electrical charge and anchoring groups define dispersant performance and stability. You may wonder how to select the right dispersant for your case. So here are the key decision factors when choosing a dispersant. The first step is defining the system type, whether water-based, solvent-based, or universal. Next, the resin and pigment type, as well as whether the formulation is a concentrate or a direct grind. All this must be considered. Then, process constraints, expected performance, and market requirements guide these choices. Finally, pigment concentration and regulatory demands like VOC limits or eco labels strongly influence the final dispersant selection. These are typical dispersant dosage ranges expressed as percentage over pigment weight. Low surface area materials like mineral fillers and titanium dioxide require relatively small amounts of dispersant. Inorganic pigments need slightly higher dosages due to increased surface activity. And organic pigments, especially phthalocyanines, demand much higher levels because of strong particle-to-particle interactions. Carbon black with extremely high surface area requires the highest dispersant dosages to achieve proper stabilization. You see now the main dispersants for solvent-based systems from Disamtex, with a short and generic explanation of their chemical composition or their application intent. And one that is commonly highlighted is Disacode DIP to 100. And this slide maps the name of Disamtex's dispersing agents by technology level, the x-axis, versus performance, which is the y-axis. Yellow bubbles show solvent-based dispersants for architectural coatings, offering solid performance with conventional technology. Blue bubbles represent solvent-based dispersants for industrial applications, delivering higher performance for demanding systems. And the green bubble, DIP 7800, highlights solvent-free technology, combining high performance with improved sustainability. So overall, it illustrates Disamtex's portfolio evolution from traditional solvents to high performance solvent-free solutions. Okay, and this slide compares Disacode dispersants from Disamtex, covering solvent-based technologies and one solvent-free. On the left, DSE, DS7000 and DS1515 are high solids dispersants designed mainly for alkyd enamels in mineral spirits. In the center, DS 1630, 70 and DIP to 100 are more versatile options, including different systems using either aromatic or acetate solvents. And further on, DIP 7800 is our solvent-free dispersant, which also works well in several systems. And Disacode MB for master batches. The orange dots highlight where each product delivers best dispersion performance across fillers, titanium dioxide, inorganic and organic pigments. These for water-based systems. I tell you the most popular one is currently PCW 8500. Again, a subdivision of Disamtex products according to what the dispersants are usually for and their chemical nature basis, highlighting how they perform best. This is the type of presentation Disamtex gives to those willing to grind organic pigments in water-based systems. A whole pack of additives that perform well synergistically and give great outcomes in the paint. if the customer's case is inorganic pigments, then there is also a combination of products. Same with mineral fillers. In bold letters, our latest best recommendation. Another important aspect of using good dispersants is to avoid pigment migration, like floating and flooding. Floating is a vertical pigment separation where color strength gets concentrated unevenly, making the film look differently than intended. And this effect can be detected with tests like rub out, revealing hidden color differences. And flooding, on the other hand, is a horizontal separation during drying, driven by solvent flow. So lighter pigment particles move with the solvent and form visible patterns or islands. And anti-floating additives like this one, Disacode AF 504S, help keep pigments uniformly distributed through the film. Additives with silicone like AF 504S work by anchoring onto pigments, improving wetting and surface compatibility, and their structure stabilizes pigments through steric hindrance, reducing flocculation. Dispersing and wetting additives surround pigment particles with polymer chains, and this locks pigments into the resin matrix and limits their movement during drying. So as a result, all pigments behave similarly, preventing both floating and flooding defects. All right, excellent. That's all from me, and I thank you for your dear attention. I make myself available, and we hope our conversations can go further, so feel free to get in touch.